In the previous two lectures, we have seen how we can solve model number 1 of calendar problems. We have already completed model number 1, that is to find the day of a particular date. This we have already completed model number 1. Now let's go to model number 2, which is I will start with a question. If today is Friday, what will be the day after 80 days? So in this type of question, first we will take it for granted that today is Friday. It may be true or it may not be true, but as it is given in the question, we have to take that today is Friday. So after how many days? After 80 days. Now we have to find the odd days. How will we find? By dividing with the number of days in a week, that is 7. So how will we solve 80 by 7? What we need is the remainder. So 7 ones 7, 1, 0 again 7, and remainder is 3. This is what we are concerned with. So there are, when 80 is divided by 7, or in other words, for 80 days there are 3 odd days. So as today is Friday, if there is one odd day, the next day will be Saturday. If 2 odd days, Sunday. 3 odd days, it will be Monday. Plus 1, plus 2, and this is plus 3. So Friday plus 3 odd days will give us Monday. This is very easy. This is how you have to solve the model number 2. Today's day is given, and you will be asked to find the day of the week after some x number of days. Now let us go to model 3. What is given in model 3 is the calendar of 2001 repeats in which year? In which immediate year? So what does that mean? It means if the entire calendar has to be same, that means 1st January 2001 should be the same as 1st January of 2000X. So how will we find out? For this, first we have to calculate the number of odd days in each year. 2001 will have 1 odd day. 2002 same 1 odd day, because these are normal years. 2003 will also have 1 odd day. Now coming to 2004, as it is a leap year, it will have 2 odd days. So let us add these odd days. 1 plus 1 2, plus 1 3, plus 2 5. 2005 will have 1 odd day. 2006 will have 1 odd day. So from calculating from 2001, there are 1 odd day in 2001, 1 in 2002, 1 in 2003, 2 in 2004 as it is a leap year, 1 in 2005 and 1 in 2006. These total will be 7. So total of 7 odd days. We know that when 7 odd days, these number of odd days have to be divided by the number of days in a week to give the remainder. So by 7 will give 1, is exactly divisible by 7, and there will be no remainder. That means having 7 odd days is just like having no odd day. That means the odd day will be 0 at the end of 2006. At the end of 2006, odd days will be 7, or in other words 0 odd days. So 2007 will have the same calendar as that of 2001, because at the end of 2006 there are 0 odd days. So 2007 January 1st will again start from Monday, as is 2001 January 1st, which is also a Monday. And as both these years are normal years, one of them is not a leap year, so there is no chance of varying of calendars. Once the first date of January 1st falls on the same day, both the years will have the same calendars because both are normal years. So this is how you have to find you answer model number 3. The calendar of certain year is given. So while calculating the odd days, you have to include the calendar of the first year which is mentioned in the question. If the calendar of 2001 repeats in which year is the question, then you have to include 2001 in calculating the number of odd days. This is the first point you have to remember. Then second point you have to remember is whenever a leap year comes, you have to add 2 odd days. Then the third point you have to remember is you have to keep on calculating the number of odd days until you get either 7 or multiples of 7, that is 14 or 21 or like that. Until you get them, you have to keep on adding the odd numbers of the next years, because only when you get 7 or multiples of 7 they will be exactly divisible by 7, which is the number of days in a week, and you will have no remainder. Our aim is to find an year after which there will be no remainder, and that year in this case is 2006, where 7 odd days will be added up to 2006, and after 2006 there will be no odd day. That is, at the end of 2006 there will be 0 odd days. So 2007 January 1st will be Monday, which is exactly same as 2001 January 1st. And as both these years are normal years, the calendar of 2001 can be used again in 2007. If you have the calendar of 2001 and if you don't throw it away, again you can use it in 2007, because the dates and the days will coincide. So these are the 3 types of models we have that will be usually asked. So the progression will also be the same. Model number 1, which we discussed, is most frequently asked, so practice them more. Model number 2 is not that important, and it is around I can say about every alternate exam you will have a question like that. And model number 3 is considered a difficult question, a very difficult question, and is rarely asked, usually asked in civil services. And but be prepared, so that if the that type of questions are asked, most of the people will not be able to answer, because they will be confused between the leap years. While calculating the odd days, they will be confused with the leap years, and they will not know that the final year, that is in this case 2006, they will usually mark 2006 as the answer, because we have ended the calculation here. But you have to remember that 2006, end of 2006, you will get the odd days as 0, so the next year will be the answer. So practice these 3, practice model number 1 more. Because this is easy to practice, you can take any date at random and you can try to identify the day of the week. You identify your birthday, when you were born, identify which day it was. You can practice by using your friends' birthdays or anything. So practice it more, and this is rarely asked, but be ready to answer this type of questions also, because it will give you a lot of edge over others.